We have another system set up here, a very simple system. We have a toy car, Hot Wheels car. We have a pulley over here, and this is a good pulley, unlike the one we used in the preceding. You see, if I spin it, it remains spinning for quite a while. It's plastic and quite light, so it doesn't add a whole lot of mass or, as we'll see later, moment of inertia to the system. The car, if you can see, has 6 paper clips attached to it. And what we're going to do is we're going to simply transfer one paper clip at a time to the existing paper clip that's hanging over the pulley. Now first, we release the system with the single paper clip, and let's see if it'll go. Okay, that works pretty well. We see the car accelerating, and the acceleration should be pretty uniform here. This is a nice solid piece of maple, pretty smooth. The Hot Wheels car has pretty low friction. Of course, the force that gravity exerts downward on this paper clip, excuse me, the force that the gravity exerts downward on this paper clip is not all that much greater than the frictional force between the wheels and the bearings and so forth. And we don't need to talk too much about that. Incidentally, you'll notice my artwork up here. Not my artwork, it's a piece of artwork, and it's there simply to keep the camera in focus. So if you have other suggestions about things that we might hang here, they're welcome. But for right now, we'll go with this particular piece of artwork that I found in a back room somewhere. Lighthouses are pretty cool, so I have no compunction about that. Now I'm going to release this in a manner very similar to what we did with the Atwood machine, the pulley that didn't work and the hanging paper clips and spools of thread. And what we're going to do is we want to time how long it takes to get from here to here. Now I'm just going to time this using my 1001, 1002 count, and I'll make my estimates, and you can refine them in any way you prefer. You can stop frames on a video, you can use a stopwatch, you can use the computer timer that you'll be introduced to fairly soon, or you can just count. Another way to do this is just try to count in a steady 1, 2, 3, 4, 5, 6, 7, 8. Probably want to start with 0. 0, 1, 2, 3, 4, 5, 6, 7, 8. 0, 1, 2, 3, 4, 5, 6, 7, 8. Or 0, 1, 2, 3, 4, 5. Can't talk. Not having a great morning here, but not bad. Okay. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you go to 11, 12, 13, your count tends to slow down, so I tend to repeat a 0 through 10 or a 0 through 8, which has a nice 4-beat rhythm, and you can get a pretty good indication of how long it takes something to happen if you keep a steady count. In any case, any number of ways we can time the car from here to here. You don't have really great parallax, but the car is pretty close to this domino. So we're going from this line till the front of the car reaches this domino. And here we go. I'm going to release on 3. 1, 2, 3. Okay, I got something a little over 4 seconds, but I wasn't doing that really precisely, so I'm going to say again. 1, 2, 3. Whoops. Didn't get much there because the thread slipped off of the pulley, and I know that happens. I was just so excited to have a good pulley. Well, I don't know why that thing keeps slipping off of there. Probably because I'm not putting it on very well. Okay, ready. 1, 2, 3. Okay. And that time we actually had a collision with the domino. That actually worked out pretty well. Getting something a little over 4 seconds. We'll do one more run, and then we'll. Yeah, this thing must not be clamped on there quite parallel. I have to look at that when I pause the video. Are we ready? 1, 2, 3. Okay, I got something closer to 5 seconds that time. And I noticed that the car got a little bit of a slow start here. That'll be less of a problem as we increase the number of paper clips. So I'm going to add a paper clip over here. Got my glasses on because it's dark thread on a dark pulley against a dark background as I see it. Okay, we ready? There are 2 paper clips. 1, 2, 3. Okay, little glitch at the end there. I got something pretty close to 3 seconds. Okay, ready? Aim the car just a little better. Okay, 1, 2, 3. Yeah, maybe a little under 3 seconds that time. Okay. I'm going to transfer another paper clip. So now there are 3 paper clips. Ready? 1001, 1002, 1003. Definitely under 3 seconds. We did stay on the pulley that time. Ready? 1001, 1002, 1003. I realized that I might have been blocking the car as I reached out. One of these days I'll get that straight. Okay, are we ready? Again, 3 paper clips, 1001, 1002, 1003. Okay, transferring a 4th paper clip. Ready? 4 paper clips. 1001, 1002, 1003. Again, I reached with the wrong hand. Let's try this again. 4 paper clips. 1001, 1002, 1003. Came off the pulley. Oh, just wrecked everything. Okay, that's supposed to be a 2-hand span. I think that's about where it was before. We have enough uncertainty in this experiment that that doesn't make a huge difference. Try to minimize it. Okay, we got 3 more paper clips. Okay, transferring another one, so there are 5 paper clips. Ready? 1001, sorry. 1, 2, 3. Okay, again. 1, 2, 3. And once more. 1, 2, 3. Okay, another paper clip, if I can. Things are kind of wiggling and twisting. Okay, there we go. Now that's 5 and 1, 6. 5 and 1, 6 paper clips. Ready? 1, 2, 3. I was late on that. Sorry. Ready? 1, 2, 3. Another collision. Again. 1, 2, 3. One more. 1, 2, 3. And transfer the last clip. See what we get. Ready? Now that's 5 and 2. That's 7 clips down there. 5 and 2, 7. Ready? Now, 1, 2, 3. Again. 1, 2, 3. And again. 1, 2, 3. Now, when we have a lab, we're going to run this experiment again, and we're going to run it with the greatest precision we can achieve, which will probably involve recording a sound at the instant the car is released, recording another sound at the instant the car collides with some sort of a barrier at the end of the run. And we'll measure the distance more accurately. This distance will take as 2 handspans. We should be able to measure the time between release and the end, well, down to the 10,000th of a second or so. That'll be excessive because we won't be able to measure the distance to that sort of accuracy, but it'll be an interesting experiment. So we're going to refine what we get here, but for now we have, I think, some the potential from this video to get some pretty good data.